Hello everyone. What exactly is a deadlock? In simple terms, it's a situation where two or more transactions, or processes, are blocked indefinitely, waiting for each other to release resources that they need. Imagine transaction A has a lock on the payments information and needs the orders information, which is locked by transaction B. At the same time, transaction B has a lock on orders and is waiting for payments, which transaction A has. They're in a standstill, neither can proceed. Now, how do these deadlocks actually happen? There are some specific conditions, often called the Kaufman conditions, that need to be in place. Think of them as the ingredients for a deadlock recipe. Mutual exclusion, this means that at least one resource being used cannot be shared. Like a single printer, only one person can use it at a time. Hold and wait, a process is currently holding on to at least one resource and is waiting to acquire additional resources that are being held by other processes. So, transaction A has payments locked and is waiting for orders. Circular wait, this is the key ingredient for a full-blown deadlock. There's a chain of processes where each process is waiting for a resource held by the next process in the chain. In our example, A waits for B, and B waits for A, forming a simple circle. But it can be longer too. No preemption, resources cannot be forcibly taken away from a process that's holding them. You can't just yank the payments lock away from transaction A, for example. So, we've got these conditions, and they lead to our transactions blocking each other. Let's look at a simple step-by-step example to really nail this down. Imagine we have transaction A and transaction B dealing with a database of payments and orders. Step 1. Transaction A updates the payments table, setting the status to done for a specific order, let's say order_ID equals 100. It now holds a lock on the payments related to this order. At almost the same time, transaction B updates the orders table, setting the status to paid for the same order_ID equals 100. It now holds a lock on the order information. Step 3. Now, transaction A needs to get more information about the order, select asterisk from orders where order_ID equals 100. But wait. Transaction B has a lock on that order information, and it's not releasing it yet. So, transaction A is now waiting. Step 4. At the same time, transaction B needs to get information about the payment, select asterisk from payments where order_ID equals 100. But guess what? Transaction A has a lock on that payment information and is waiting for the order info. Boom! We have a deadlock. Transaction A is waiting for a resource held by B, and transaction B is waiting for a resource held by A. Neither can proceed, and they'll be stuck forever unless something intervenes. So, what can we do about these pesky deadlocks? There are two main approaches, deadlock prevention and deadlock recovery. Deadlock prevention aims to stop deadlocks from happening in the first place by making sure one or more of the Kaufman conditions never occur. Some strategies include strictly increasing order of resource requests. Each process must request resources in a specific, predefined order. If they can't get the resources in that order, they release any they already hold and try again later. This breaks the circular wait condition. Ensuring no hold and wait, processes must request all the resources they need at once. If any resource is unavailable, they don't get any and have to try again later. Allowing preemption, in some cases, if a process is holding a resource and needs another that's held by a waiting process, the resource can be taken away from the holding process, temporarily. The banker's algorithm. This is a more sophisticated approach where the system simulates the allocation of resources to ensure that a safe state, where all processes can eventually finish, is always maintained. On the other hand, deadlock recovery deals with situations where a deadlock has already occurred. The system needs to detect the deadlock and then take action to resolve it. Common techniques include: select a victim. The system identifies one or more of the deadlocked processes as victims. Rollback. The victim processes are then rolled back, meaning their partially completed work is undone, and any resources they were holding are released. These processes can then try to acquire the resources again. Let me know in the comments below. Thanks for watching.